Right under our feet, beneath our cities, our oceans, there is a fire. And it's not a normal fire. It's this colossal planetary engine of heat that's been burning for billions of years. We're about to take a journey deep into the Earth to find out how this hidden power just might be the future of all energy. I mean, just think about that for a second. It's a simple question, right? But the answer, well, it could literally change everything. We spend so much time and energy looking up, at the sun, at the wind, but what if the real key to our clean energy future has been right here, just by looking down?
10,800 degrees Fahrenheit. Let that number sink in. That is the insane temperature of the Earth's core. To give you some perspective, that's as hot as the surface of the sun. This isn't just some random number. It's a measure of the unbelievable amount of thermal energy just churning away deep inside our own planet.
And that, my friends, brings us to our topic, geothermal energy. The name really says it all. Geo for Earth, therm for heat. We're talking about the science and the incredible tech of tapping into this natural furnace to power our modern world.
So, you gotta be asking, how does our planet stay so incredibly hot? I mean, it's not like a simple campfire down there. It's this wild process that's been going on for eons, powered by forces that were forged at the very dawn of our solar system.
This heat is, for all practical purposes, endless, and it really comes from two places. First, you've got primordial heat, basically the leftover energy from when our planet was just a giant, violent ball of molten rock. But the second part is the real key, radioactive decay. Deep in the Earth's core, elements like uranium are constantly breaking down, which makes our planet, in essence, a giant, slow-burning, natural nuclear reactor. An engine that is not going to run out of fuel for billions more years.
Okay, so it's one thing to know this massive furnace is down there. It is a completely different challenge to actually bring that power up to the surface and, plug your phone into it. So how do we do it? Well, this is where some really brilliant engineering comes into play.
So let's break it down. We're going to look at the most common way to turn all that Earth heat into the electricity that powers our homes. How do we get from raw steam to a reliable current in the wall socket? All right, take a look at this. This is the schematic for what's called a single flash power plant. Now, I know it might look a little complicated, but the core idea is actually beautiful in its simplicity. Let's break down exactly how this thing works. Okay, let's walk through it. First, we drill way down into a natural underground reservoir of super hot water that's being held under incredible pressure. Then, when we pump that water to the surface, the pressure plummets. It's kind of like shaking up and opening a soda bottle. The water instantly flashes into a really powerful jet of steam. That steam is then used to spin a turbine, the turbine spins a generator, and just like that, bam, you have electricity. And to make it sustainable, we cool the steam back into water and pump it right back down to get reheated. It's a clean, elegant, and totally continuous loop.
Now, this thing, yeah, it might look like your worst nightmare from a physics final, but for an engineer, this chart is basically a treasure map. They use these thermodynamic roadmaps to track the energy in every single drop of water, making sure they squeeze out the absolute maximum amount of power at every single stage. It's the hidden science that makes geothermal so powerful.
And listen, this isn't just some science fiction concept. Geothermal power is a proven technology. It's got a history stretching back more than 100 years, and it's already providing clean, reliable power to millions of people all over the world. The whole journey started way back in 1913 in Largest, Italy. Fast forward to 1960, and the United States got in the game with a massive complex in California called the geysers. And today, it's a global industry. We're talking over 30 countries harnessing the power that's sitting right beneath their feet. And get this fact alone just blows my mind. That original site in Largest, Italy, it is still operating today. For more than a century, it has been a living, breathing testament to just how sustainable and durable this technology really is. And over in California, the geysers complex is a true titan. It generates enough electricity to power a city the size of San Francisco. But here's what's so cool about it. It uses treated wastewater from nearby communities for its injection wells, so it's recycling 20 million gallons of water a day to keep the whole thing running. So clever. But what's geothermal's biggest superpower? You're looking at it. Unbeatable reliability. I mean, the sun doesn't always shine, the wind doesn't always blow, but the Earth's heat, it's always on. Geothermal plants run over 90% of the time. That means they provide that steady 24/7 power that our electrical grids desperately need. It's a total game changer.
And they do all this while being incredibly clean. A modern geothermal plant produces 99% less carbon dioxide than a fossil fuel plant of the same size. It is easily one of the cleanest forms of energy on the entire planet.
So, if it's so great, why isn't it everywhere? Well, for all its amazing benefits, traditional geothermal has had one big limitation: geography. You had to be in the right spot. But a new generation of technology is about to shatter that barrier and make geothermal possible almost anywhere on Earth.
See, traditionally, you needed this perfect storm of three things: hot rock close to the surface, naturally flowing water, and rock that was porous enough for the water to move through. That combination is pretty rare. But enhanced geothermal systems, or EGS, completely change the game. With EGS, you only need one thing: hot rock. We can engineer the rest.
The concept here is just revolutionary. We drill deep into hot, solid rock. Then we pump water down at a really high pressure to create a whole network of tiny cracks and fissures, a man-made reservoir. From there, it's easy. We just circulate water through it, let the Earth's heat do its thing, and create the steam to drive our turbines. We can basically build a geothermal resource exactly where we need it most.
And the innovation isn't stopping there. Researchers are now developing these wild new closed-loop systems, which act like giant underground radiators. These could make the whole process even more efficient, eliminate any risk of water loss, and really push geothermal energy into its next great chapter. Okay, so after our journey deep into the planet, let's bring it all back to the surface. Why is this hidden fire so absolutely critical for our energy future?
Let's just recap the geothermal advantage. It's always on, giving us power day and night, rain or shine. It is incredibly clean with pretty much zero emissions. It's also super compact. A geothermal plant can make the same amount of power as a 400-acre solar farm on just a handful of acres. And most importantly, it taps into a source of energy that is, for all of us, truly inexhaustible. So it really leaves us with this one powerful question. As we search for solutions to our massive energy challenges, maybe we've been overlooking the biggest one of all, this silent giant just churning away right under our feet. If you enjoyed this journey into the Earth's hidden power, do me a favor and be sure to like this explainer and subscribe for more deep dives into the science and technology that are shaping our world. Thanks for watching.